Hi, today is the big day where we put everything together. Radians, degrees, all students take calculus, reference angles, coterminal angles. Okay, so some reminders before we start putting everything together. All right, we know that cosine stands for the horizontal length, x. Sine stands for the vertical length, y. So, going back to everything is based on our right triangle in the unit circle in the coordinate system. So I don't know if you can see that, but that is a right triangle labeled x, y, and of course our hypotenuse is r. And r is a hypotenuse, so it's always positive. And then this is a unit circle, which means the radius is 1. So this is the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So, as a reminder, when we have a right triangle and a unit circle, let's set up our 6 trig ratios. Sine is so, opposite over hypotenuse, so it's y over r. Its partner or reciprocal is cosecant, so it's r over y. All right, cosine of theta is ka, so ka toa, adjacent over hypotenuse, so x over r. Its reciprocal is secant, which is r over x. Tangent is toa, opposite over adjacent, which is y over x, or sine over cosine. And then cotangent is its reciprocal, which is x over y. Now, let's get into actually finding all of our different trig ratios of very common angles. All right, so the first angles we're going to talk about are quadrantal angles. So remember that vocabulary word. Quadrantal means I'm looking at angles that will not make a triangle and they will either be 0 degrees, 90 degrees, 180, 270, or 360. Okay, so first of all, cosine of 0. Remember, cosine is your x-coordinate or the horizontal distance. So the cosine of 0 degrees or 0 radians is 1. All right, and if you think about y, when you go to 0 degrees, you have gone the entire length of the radius, and the radius is 1. Sine of 0 degrees or 0 radians is 0. Think about that. To get to 0 degrees, you didn't go anywhere vertically. Cosine of pi over 2 is 90 degrees. Cosine is 0. Think about why that cosine of 90 is 0. When you went here, you did not go anywhere horizontally. Sine of pi over 2 is 1. Okay, it's the y-coordinate. Also, when you go to pi over 2, to go from 0 to pi over 2, that is actually the radius, which is 1. All right, cosine of 180 is negative 1. Sine of pi is 0. Cosine of 270 is 0. Sine of 3 pi over 2 is negative 1. Cosine is x, sine is y. I kind of remember it as c is before s, x is before y. All right, cosine of 360. Now, bringing up the idea of coterminal angles. Coterminal angles share the same ratio. So, for example, 0 and 360 are coterminal. So the cosine of 360 is 1. The sine of 2 pi is 0. Now, how about the tangent of 90? Well, we have to know, yes, it's opposite over adjacent, but at quadrantals, we don't have a triangle to set that up. So we have to know that it is sine over cosine. Sine over cosine would be 1 over 0, which is undefined. To understand, we've said that sine is the vertical distance of the length of a triangle inside the circle, and cosine is the horizontal, okay? Tangent is actually like a tangent line that you learned in geometry, but it is a tangent line that touches the circle vertically. So if you're at 90 degrees, you don't have a tangent line touching the circle vertically. That's why it's undefined. All right, cotangent of pi over 2, you would take the reciprocal, that's 0. All right, tangent of pi is sine over cosine, so that would be 0. Cotangent of 180 would be negative 1 over 0, cosine over sine, so that is undefined. Secant of 90, okay, when we have our reciprocals, remember I've encouraged you, go to their partner, either sine, cosine, or tangent. All right, so secant of 90, its reciprocal is cosine, so cosine of 90 is 0. So now if I take the reciprocal of the ratio, I get undefined. All right, let's add one more to this. How about the cosecant of 450 degrees? All right, well, let's graph 450 degrees. 450 degrees, I would come around once, that's 360. 360 plus 90 is 450. So 450 is coterminal with 90. So I'm really looking at the cosecant of 90 degrees. Well, we don't know cosecant well, but we know its partner well. The sine of 90 is 1, so the reciprocal of 1 is 1. Okay, so now that we know the specific values for quadrantal angles, let's review our specific values for our triangles. Okay, so go ahead and draw in your 30, your 45, and your 60. So if you need to stop the video to do that. Remember, your smallest side is always 1. We've talked about that. All right. So now you're going to see that these angles are going to be the foundation for figuring out the ratios of all of the other angles in the unit circle. All right, so what is the sine of 30 degrees? Opposite over hypotenuse, it is 1/2. What is the cosine of 30 degrees? Adjacent over hypotenuse, square root of 3/2. What is the sine of pi over 3? Well, we should know that that's 60 degrees, so that would be square root of 3/2. So by the way, you may want to stop this and fill these out and then come back and check with the video. Okay? Secondly, these are ratios that you are going to need to know. Okay? All right, cosine of 60 degrees is 1/2. Sine of 45 degrees is either 1 over square root of 2 or square root of 2/2. Either one is fine. Cosine of 45 degrees or pi over 4 is 1 over square root of 2 or square root of 2/2. You can also see why I've said you've got to know your degrees and radians. We shouldn't have to think about that. Pi over 4 is 45 degrees. Okay, tangent of pi over 6. We should know that's 30 degrees. Tangent of 30 degrees is opposite over adjacent, so 1 over square root of 3 or square root of 3/3. Tangent of 60 degrees is square root of 3/1 or square root of 3. Let's add some other questions to this. So let's add the cosecant of 30 degrees. Okay, so cosecant, remember, let's go to its partner with which we're familiar. Sine. Sine of 30 would be 1/2. So therefore, the cosecant of 30 would be its reciprocal, which is 2. All right, how about the secant of pi over 6? All right, I'm asking what's the secant of 30? Well, let's go to its partner, cosine of 30, which is square root of 3/2. So therefore, the secant of 30 would be its reciprocal, which is 2 over square root of 3, or if you want to write it as 2 square root of 3/3. All right, how about the cosecant of pi over 3? Cosecant of 60 degrees. So I'm going to go to the sine of 60. The sine of 60 is square root of 3/2. All right, so therefore the cosecant would be the reciprocal, which is 2 over square root of 3, or 2 square root of 3/3. Okay, so now we have our foundation of quadrantal angles, and our 30s, our 45s, and our 60s. So let's do a reminder about all students take calculus. All right, remember, this is a way that tells us what's positive. All is positive in quadrant 1, sine and its partner cosecant in quadrant 2, tangent and its partner cotangent in quadrant 3, cosine and its partner secant in quadrant 4. And remember, think about why this works. If cosine is x and sine is y, that's where you're going to think about. Here, cosine's positive because x is positive. Here, sine is positive because y is positive. Here, both are negative, which makes it a positive. All right, also remember what reference angles are. Reference angles are the acute angle made with the x-axis. Okay, so we're going to be using all of this to finally, big day, put everything together. All right, so here we go. Drum roll, please. So let's take a look here. How do we find the trig ratios of angles not in quadrant 1? Okay, so first of all, if I'm asking what is the cosine of 5 pi over 6, again, we should know that's 150 degrees. We should not have to do work. So this is what I meant a few days ago. We've got to know that. Okay, the first thing I decide upon is the sign, the S-I-G-N. All right, cosine of 150. 150 is in quadrant 2, so that's negative. My answer is going to be negative. I will put that in later. Now, how do I use reference angles? Okay, so if I graph 150, it's in quadrant 2. Look what's left over. Isn't the angle made between the terminal side and the x-axis 30 degrees? Okay, so 30 degrees, we are now going to use our 30, 60, our 30 triangle. All right, my reference angle is pi over 6 or 30 degrees. So what is the cosine of 30 degrees? It is square root of 3/2. So the cosine of 5 pi over 6 is negative square root of 3/2. Okay, so you see that this is coterminal. We use our reference angle. Why do we use the reference angle? Because doesn't it make our triangle? All right, let's take a look at B. Sine of 7 pi over 4. Well, first of all, we should know right away that 7 pi over 4 is 315. Find the quadrant, take the SIG in. Sine is negative in quadrant 4. Let's graph 315. If I graph 315, what is the angle made with the terminal side and the x-axis? That is 45. All right, so we make this triangle. The sine of pi over 4, or 45, is 1 over square root of 2, or square root of 2 over 2. So the sine of 7 pi over 4 is negative 1 over square root of 2, or negative square root of 2 over 2. So hopefully you are catching on that I'm having you graph these so that you can see that the triangle you actually make is using your reference angle. Okay, let's go to C. The tangent of 4 pi over 3. Again, we should know 4 pi over 3 is 240 degrees. First thing I decide is where's this angle and what is the SIGN going to be. This is tangent of 240, so it's quadrant 3, so it's going to be positive. If I graph 240 degrees, there it is. The angle made between the terminal side and the x-axis is 60 degrees. All right, so my reference angle is 60 or pi over 3. What is the tangent of 60 or pi over 3? It is square root of 3. So the tangent of 4 pi over 3 is square root of 3. All right, so you see how we're using our triangles, our reference angles. All students take calculus and the idea of coterminal angles. Okay, how about the secant of 5 pi over 3? First of all, we should know 5 pi over 3 is 300 degrees. All right, that is in quadrant 4. Secant is cosine's partner, so it is positive in quadrant 4. So as I've encouraged you before, work with the one you know. You know cosine, and you can always take the reciprocal when you're finished. So if I graph 300 degrees, I get 60 in my triangle. My reference angle is 60 or pi over 3. What is the cosine of 60 degrees? It is 1/2. So therefore, the secant of 60 degrees is the reciprocal, which is 2. So the secant of 300 degrees, or 5 pi over 3, is 2. Okay, let's take a look at E. Cosecant of 2 pi over 3. Cosecant of, we need to know 2 pi over 3 is 120 degrees. That's in quadrant 2. All right, again, this is one of those reciprocals, so go to its partner. Cosecant is sine's partner. Sine is positive in quadrant 2, so cosecant will be as well. All right, let's graph 120 degrees. We can see that with the terminal side, that makes a 60-degree angle. That is the angle that would be in the triangle. So I'm going to look at 60 degrees. But again, I know sine better than cosecant. So let's find the sine of 60 degrees. The sine of 60 degrees is square root of 3 over 2. Therefore, the cosecant would be the reciprocal, which is 2 over square root of 3. So the cosecant of 120, or 2 pi over 3, is 2 square root of 3, or 2 square root of 3 over 3. Now, I also want to prove to you why we're using 60 degrees and why we take the reciprocal, and why taking the reciprocal gives us the correct answer. So take out your calculator, make sure you're in the degree mode. So if you need to stop the video, do that. I want you to put in the sine of 60 degrees. Okay, if you put in the sine of 60 degrees, you get 0.8660. I also put on my calculator square root of 3 over 2 to prove that this is equal. Now, you can put cosecant on your calculator by taking 1 divided by the sine of 60. And if you do that, you get 1.1547. So I checked. Is 2 over square root of 3 1.1547? It is. Okay, let's take a look at F. Cotangent of 7 pi over 6. First of all, 7 pi over 6 is 210 degrees. That is in quadrant 3. So if I graph that, I get 30 degrees. All right, I don't know cotangent that well, but I know tangent. So I'm going to take the tangent of 30 degrees. The tangent of 30 degrees is 1 over square root of 3. So therefore, the cotangent of 30 degrees is its reciprocal, square root of 3. And I forgot to mention cotangent and tangent are positive in quadrant 3. Now, question I always get is, Mrs. Evans, do I have to graph this every time? No. I wanted you to see the graphs so that you understood why I say you can just use the reference angle. When we graphed our angle, didn't we end up making a triangle that had the reference angle? So you don't have to graph every time, but you have to use the reference angle. If you want to graph, that's fine. So let's try G without graphing. All right, so I'm asking, what is the cosine of negative pi over 6? Or in other words, what's the cosine of negative 30 degrees? So let's go ahead and find where it is. Negative 30 is in quadrant 4, cosine's in positive in quadrant 4. What is the reference angle for negative pi over 6? It's pi over 6. It's 30 degrees. What's the cosine of 30 degrees? Square root of 3 over 2. So the cosine of negative 30 degrees is also square root of 3 over 2. All right, let's take a look at H. What is the sine of negative 3 pi over 4? So I'm asking, really, what is the sine of negative 135? Well, location. Negative 135 is in quadrant 3, so the answer is going to be negative. What is the reference angle for negative 3 pi over 4? It's pi over 4. What's the sine of pi over 4? 1 over square root of 2 or square root of 2 over 2. So the sine of negative 3 pi over 4 is negative 1 over square root of 2 or negative square root of 2 over 2. So do you see how I use the reference angles? All right, now this negative has nothing to do with the fact this angle is negative. That just told me location. All right, let's take a look at I, tangent of negative 60. Negative 60 is in quadrant 4, and so its sine will be negative. What's the reference angle for negative 60? It is 60. So the tangent of 60 degrees is square root of 3, but I'm in quadrant 4, so the answer is negative square root of 3. Last problem. How about the tangent of 420 degrees? Okay, well this probably is one, when we get an angle bigger than 360, probably one that we need to graph. So if I graph 420, I go around once, that's 360. 360 plus 60 is 420. So coterminal angles share the same ratio. So my reference angle is 60, so I'm in quadrant 1. Quadrant 1 is positive. My reference angle is 60. What's the tangent of 60 degrees? Square root of 3. So the tangent of 420 is square root of 3. So hopefully now you see why we needed to know our unit circle, why we needed to know our special triangles, the 30s, the 45s, and the 60s, why we need to know reference angles, and why we needed to know all students take calculus.